Good afternoon, everyone. This is Vaibhav here. So let me just continue with the previous session which I have left before. Like I just share my screen now. Okay.
What is that noise?
Sir,
Some background noise is coming. Vaibhav, is it yours or someone else?
let me just look through it, sir.
Now it's okay. Now it's okay.
He has
Yeah,
muted it.
yeah. So it's Vaibhav's. So
Okay.
can you reduce that noise or can you switch off the fan or something?
I just switched off my fan, sir. Like I
Oh,
hope no
okay.
background noise would come
Yeah,
now.
sure. Thank
Oh,
you.
yeah,
Thank
thank
you.
you. Yeah, okay, sir. Okay. Just give me a minute, sir.
Vaibhav?
Yes, sir. I'm here. Like actually, like my VPN got disconnected. I'm just trying to reconnect it, sir.
Yeah.
Sorry for the inconvenience. And just
Vaibhav, can you just close the 40 client and then restart the 40 client?
Yeah, yes, sir. I'll just try it now. So, like, actually, like, I don't know what happened. Like, I couldn't able to open the Firefox browser. This was open. Hmm, okay.
What happened?
Sir, like, the browser is not opening, sir. It says that it is already running and but it's not responding.
So you may kill the process and then you may restart it, right?
Yeah, sir. I just did that, but actually, like, it is showing that it's already running. So that's what I'm looking after. It.
Eh,
Yeah, it's coming. Okay, fine. Yes, I'm sure. Okay. Okay, fine. All right. So okay, fine. So, okay, participants. So, I have left until here actually, like the visualization part. So, once we could visualize it, we can able to find that as the years of experience increases, the salary of the employees is also being increased. And the final part of this particular program would be calculating the residuals. That is residuals in the sense the mean absolute error, the mean squared error, and then the RMSE values. So, with the tested data as well as the trained data, we could able to find this absolute error and the mean squared error. So once after we run this particular command, we could able to get the mean absolute error value of 4971, and then the mean squared error value of this 3962 6080, and then the RMSE value of 70. So one can have a doubt of what these values actually mean. So like this mean absolute error should range between 1 to 10,000. So if a model has a mean absolute error value of between 1 to 10,000, then that model has been performed well, like, or it has performed better. So here in our case, the value is 4,971, and similarly in the case of the RMSE value, we have around 70.50. So the RMSE value should range between 1 to 1000, but in our case, that is in our salary prediction model, it is around 70. So this is all about the salary prediction model. And with this, like this thing, this program gets over. Now we'll move on to our session. So here before the session, like I had a few questions, like how one could able to add the data into it. Like I can just check to the chat box actually. Like a person called Shanti B asked me like how to put it in the server, or where one can fetch the CSV file, how we can upload the data into the server and all. So here I hope my mobile XTerm terminal is open. So here once after we log into it, so we could able to see some of the folders which we have created and the files which we are. So here we can just give this icon. There is an icon called the upload icon, the download icon, and here we have a directory icon. So just by clicking on the upload icon, so we can able to choose which of the files we can able to upload. So I have just created a notepad file, so I can just by clicking open, this file will get uploaded here. So this is how we can able to upload files. It's not only we can upload the file, we can upload it as a folder, or we can even create a directory. Like in this server itself, we can able to create a directory just by clicking on this create new directory icon. So I can just give a directory name called Vaibhav. Okay, so this Vaibhav directory is now being created. I'm just switching off my this one Jupyter notebook for a minute. So now okay, fine. Now if I see whether these files are being updated in the server, by giving the this one list command, I could able to see both the text file as well as the directory which I have created Vaibhav are both being uh, uploaded or mounted to our server. So this is how we can able to upload our program. So like this one, like the people who have asked, so this is how we can able to upload our files to the server. So this is as simple as such. Okay, so if you have any other doubts regarding this, you are free to ask these. And now we can move on to the another deep learning application that is called to be as diabetic retinopathy. So now okay, yeah, okay. Okay, so before explaining the code, let me just explain this use case called diabetic retinopathy. So which I am going to explain. So this particular program is going to detect whether a person is being affected by diabetic retinopathy or not. So before that, let us know what diabetic retinopathy actually is. So diabetic retinopathy is a diabetics complication that affects an eye. So like it will cause damage to the blood vessels that are present inside the eye, that is the retina. So here this particular diabetic retinopathy causes to people who have type 1 or type 2 diabetics. So the longer you have diabetics and less control your blood sugar is, you are more likely in order to develop this diabetic retinopathy complication. So here we are trying to gather some data, and based on those images we are going to diagnose the level of diabetics into 5 categories such as 0, 1, 2, 3 and 4, which means that if the data is labeled as 0, then that particular person is not affected by diabetic retinopathy. If it is labeled as 1, he has mild diabetic retinopathy. If it is 2, it's moderate, 3 is severe, and then 4 is the proliferate diabetic retinopathy, that is the extreme case. So it could be possible we need to test the level of diabetics in remote areas where doctors are not available in order to diagnose this disease. So there should be some automated system which could be easily to classify the diabetic level based on the retina image without any doctor's interference. So here since we are living in a city, we can just able to consult the doctor and then we can take the treatment accordingly. So now in the place in a remote place where there are very less to no number of doctors, in that case it is very difficult to check whether a person is being affected by diabetics or if a person is being having this diabetic retinopathy. So in that case we could have some automated system which is programmed with this particular diabetic retinopathy program, and with that we could able to diagnose whether a person is affected by diabetic retinopathy or not. So those devices can be some edge devices which can be connected to medical devices, so that we could take a live picture, like live picture of the patient or their eyes, and system could correctly identify the diabetic level based on the retina image that has been captured, and this system could be performed completely offline. So now let us talk about the solution provided. So this customized model uses the deep learning approach and executors and train the algorithm on a POWER9 platform. So here are these 5 categories from 0 to 4. So these images are being pre-processed, because like we gathering a lot of data could be quite difficult. So we are trying to pre-process the data which are being rotated into 90 degrees, 180 degrees, and then 270 degrees, in order to make the dataset more accurate for training. And this particular extended dataset has around 140,000 of images. So this particular model is being created on a POWER9 platform, and the images data is ported to the POWER9 system for training, and it is done using 4 Tesla V100 GPUs. So once the training is being completed, it will generate a model as an output, whether the patient is caused with the 0 or the proliferate diabetic retinopathy. So from our purpose, like we can just able to execute the program and go, like for our problem statement, that is in order to carry such operation in a remote places. So this particular model could be inserted in a edge device. So here we call the edge device as the Jetson Nano, which is being powered by NVIDIA. So Jetson Nano is a portable device that runs as little as 5 watts of power. So alternatively, this model could also be deployed on cloud service, which could get the inference from local system by uploading the image. So this can also get cloud service connectivity. So retina image capturing device captures the image of the patient and sends the image to the cloud or the local edge device, which runs the model, and then it calculates the level of the diabetics that is being diagnosed. Later it also sends the images with marking label, like it is labeled whether the person has been diagnosed with diabetic retinopathy or not, to the POWER9 system, which will further enhance the model based on the new images. So as we take images, it tries to mark the labels accordingly. If the retina capturing device is a portable device working in remote areas with no internet connectivity, we can design a new device in order to adapt the model on the hardware and do the inferencing on new images captured offline. So here if there is no internet connectivity, in that case we can adapt the model into a new device, and then the inferencing can be done in the offline mode. So now we have a pictographic representation of how this is actually being done. So here we have the dataset, the high resolution label dataset. So it is being augmented. It is being pre-processed and then augmented in order to increase the size of the dataset, and then it is being moved on to the POWER9 system model training. So the model is being trained now. So once after it is being a trained model, it can be for inferencing the output from the trained model on the Jetson Nano. So once after it is being inferenced, it can be moved on to the Jetson Nano, and then either from the trained model or from the retina image capturing device. So it can be a camera or something like that. So from that we can able to capture the retina, and then we can able to see whether the patient is being infected with diabetic retinopathy or not. So this feed to train the model again with the new images, or inferencing could be done on cloud, sending image to the cloud, or model could itself be deployed on its device to do the inference. So if it has internet connection, then it could be sent to cloud. If it is a very remote place, then the edge device itself could do the inferencing. So this is how it actually works. So now this particular application uses convolutional neural network model that has been created on the 35,000 images of labeled retina images. So this model uses VGG16 network architecture to get trained from scratch on Power9. So here this VGG16 network is nothing but there are 16 layers of convolutional neural network which is being used for training this particular data set. So the original 35,000 images are being augmented. So that's what we spoke about, are being rotated into 90 degree, 180 degree and 270 degree in order to make them augmented to around 1,40,000 images, out of which 20% of the images are validation set images, which are used to validate the training accuracy during the process. Okay, so this model has at like till 50 epochs it got around 97% of this accuracy, and this model is also being in this particular program is also can be accessed in the GitHub using this link, which could be shared later. Now let me demonstrate about the dataset. So firstly, we can just log into our Power9 system, and here is what the thing is. The dataset is around 80 GB. So it's around 82 GB. Like we can see about 80 GB. So this has more than 35,000 images in the training dataset, which has a range of 4,000 into 4,000 pixels. So each image could range around 8 to 10 MB. So that is what it is. Extremely HD image. So now these images are being pre-processed and are scaled down to 256 by 256 pixels and are being augmented by rotating 90 degree, 180 degree and then 270 degree. So from 4,000 by 4,000 pixels, it is being pre-processed and scaled down to 256 by 256 pixels. So once after the data augmentation part is done, now it is time for us to train the CNN algorithm over this data. So and also another thing is that since we use VGG16, it is a pre-trained model which can be used for millions of data, so that training this model could be very much easy when using VGG16. So once the training completes a certain number of epochs, it generates a model in the models directory with appropriate recall values. This model contains the weights and biases of the complete.
Can you please go to the presentation mode? It's a little bit in the smaller size.
Yeah, sure, sir. Sure. Is it okay now?
Yeah, sounds better.
Yeah, okay, sir. Fine. So we could able to take the recall values, and this model contains the weights as well as the biases of the complete training. So once this model is being trained, so once after all the epochs gets over, we need to make it enable to run the inference in an edge device. So that is what our main objective is. So in this case, we have the Jetson Nano as an edge device. So once this Jetson Nano is running like with the model, we can also install the TensorFlow framework on the Nano for the purpose of inferencing. So now let me just show you the data set. So we have it over here. Mm, mm. I got it. Okay. Okay, fine. It's okay. Mm. So here, this is how our Jupyter Notebook program would be displayed. So here, this program logic to execute the inference code on the test data, which is identified after putting all these things. Okay. So here, what we are trying to do is, we would be having two programs, like the retinopathy as well as retinopathy VGG16. So inside that retinopathy VGG16, that is where we would have had our CNN models in order to train our model, like training all those 1,40,000 images, where the training set itself contains around 85,000 images, and the rest of the images would be for the testing data set. So once after this images are being trained, so the epochs like can go around 100, but like since the data set itself is around 80 GB, so like we can just stop the data set up to the epochs up to 50. Like even if it reaches 50, the accuracy would be around 97%. So here we have a screenshot of the sample data set which is being trained. So once after we load the model, so this is how we could able to get our output. So here, as I have mentioned earlier, when these images are being comes out as output, all these images are being labeled like this: no DR, that is no diabetic retinopathy, mild diabetic retinopathy, and no diabetic retinopathy. So this is how the output would be displayed, whether the captured image of the retina is being affected by diabetic retinopathy or not. So we discussed about those five categories: no DR, mild, and then up to proliferate. So based upon the severity, it shows us whether the person is affected by it or not. So this is how this particular model will show us the result. So with this, I conclude my session. So if you have any other doubts, please feel free to ask. I am ready to answer. So thank you, sir, and thank you, everyone.
So, yeah, any queries from the participants? So, mobile XTerm, you can use that and then you can directly upload and download the files. That's point number one. I mean, I had answered that you can use WinSCP or any other similar tool. And Vaibhav has already shown that using mobile XTerm, you can transfer the files and you can run it in the Juniper notebook. Any other questions from the participants? So, if there are no further queries, Ganesh?
Yes, Sriram. So Abhishek Sharma is going to be the next speaker to talk about the augmax and other stuff. Anyway, Vinay will announce about him.
Yeah.
Thank you, Vaibhav, for the presentation.